Welcome to the next lesson. Let's jump right in and look at our think about it questions. How are these strategies helpful or not helpful for you in solving triple-digit addition and subtraction? Well, they're certainly helpful because we don't always have a calculator with us, and when we don't, we may not also have pencil and paper, and when you don't have those, it's really difficult to solve these problems unless you use these strategies. So definitely when you don't have a calculator and when you don't have pencil and paper, these are they make your life a lot easier, and they also can help you if you just need to come up with an answer quickly and maybe not even an exact answer. So the next question, if there were no calculators left in the world, which strategies would you use for triple digit addition and subtraction? For me, I think it would depend on the situation. If I were grocery shopping, I would probably use the number line because I would just be able to jump ahead in my head. But if I were doing my budget, I would probably want to use a different strategy and double check it with an algorithm just to make sure it was exact. Before we begin this lesson, I would like you to pause the video and go and collect your pencil and a piece of paper or your work log. Go ahead and do that now. So today, we're going to talk about subtraction and addition algorithms because as wonderful as it is to know those strategies, it's also important to know algorithms. And an algorithm is basically something that you use to set up a problem, a number sentence, and that helps you to solve it. Okay, but in order to use an algorithm, you really need to understand place value. So we're going to do a quick review of that. We're going to put all of these in the correct order from largest to smallest. Which one is going to be our largest? Well, we know that there are 10 blocks in this one. So I'm going to write that down so we don't forget. 10 blocks in this one. I know there's 1 block in this one. And since this flat is 10 of these longs, I know that this is 100. And then here, this is 10 flats. We have a flat, another flat, another flat, another flat, 10 of them. So we know that this is 1,000. So if we're going to put these in order from largest to smallest, I'm going to start with 1,000 because there's the most of those. And then I'm going to go to 100, 10, and 1. So this is the thousands place, this is the hundreds place, this is the tens place, and this is the ones place. And the way we write those is 1,000, 100, 10, and 1. Alright, we're going to do a little bit more practice with that now. We're going to take these base 10 blocks and write the number that they represent. Let's start over here with our hundreds flats. We have 1 100, 2 100s, 3 100s, 4 100s, 5 100s. But how do we write that number? Is it just plain old 5? No, it's not. It's 500 because we have 500 of these little cubes in each one. Now we'll move on to the tens because we're not done yet. So we have 1 10, 2 10s, 3 10s, 4 10s, 5 10s, 6 10s, 7 10s, 8 10s. Do we just write that as 8? No, we write it as 80 because here we have 80 of these little cubes. And then we have 1 1, 2 1s, 3 1s, 4 1s. Do we write this as just 4? Yes, we do, because there's each one of those numbers just represents 1. So this number is 584. This isn't just an 8, and this isn't just a 5, and well, that is just a 4. This is actually 500, this is actually 80, and this is 4. Okay, now I've given us a number and we're going to represent it with our base 10 blocks? Let's see. Let's split it apart first. So it's 368. 300. Is this just a 3? No, it's not. It is a 300. Is this just a 6? No, it's not. It's a 60. And is this just an 8? Yes, it is. It simply represents 8. So we're going to represent this with 100, 200, 300. I have to stack them on top of each other a bit. And then 10, 20, 30. And we have 6 tens. We're going to start with the traditional algorithm now. There's 2 ways to do it. You can either start on the left-hand side over here, or you can start on the right-hand side. We're going to try starting on the right-hand side. I've already drawn a representation of 38 and 84. So I have the 8 ones, and then 4 more, and then I have the 3 tens, and 8 more tens. So when I add together all my ones, I'm going to get 8, 9, 10, 11, 12. 12. That's more than just the ones place. Now I have a 10 as well. See, when I write 12, I have my ones place. So that's represented by 2 of these. But then I also have a 10. So I can trade or regroup these 10 into a long. So I don't have these over here anymore because I regrouped them. Whenever you have enough to regroup into the next place value, do it. And the way I'm going to write that in my algorithm is I'm going to write a 1 up here. Because I added, it's not just a 1. This is representing a 10. So 8 plus 4 equaled 12. I'm going to write the ones place down because this is representing my ones place. And now I'm going to add together my tens place. So I have 30 plus 80 plus 10 more because I got that from my 12. So I have 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Again, I have too many. I go beyond my tens place value. I went into my hundreds place value. So I'm going to regroup 10 of these for a hundreds flat. So I'm going to get rid of 10 of these. That leaves me with 2 tens left. So I'm going to write down 2 tens. This is actually representing 20. And then I'm going to bring the 1 over here because remember, I regrouped, so I have 100 I still need to take care of. And I'm going to, but there's nothing to add 100 to. There's no other hundreds. So I'm just going to add that in, and I have 122. It can be a little bit confusing when we're bringing in the base 10 blocks, but that can also help you to see what we're actually doing. Let's try one without base 10 blocks now. Jai loves to read. He read 245 pages in April, and then he read 806 pages in May. How many pages did Jai read between April and May? Okay, so we have our 2 numbers, 245 and 806. So, how are we going to write this? We're going to say 245 plus 806. Notice how I lined up all my place values. So the ones are lined up, the tens are lined up, and the hundreds are lined up. Let's start in our ones place. You can either picture the blocks in your head or you can just use the math that you know. What is 5 plus 6? It's going to be 11. Oh, but that goes beyond our ones place. Because if we write down 11, There's two place values there. We have our ones place value and our tens place value. We can't write that down just like 11. We have to bring our ones place value and write that here. And then we're going to take our tens place value and we're going to regroup it and make a 10 to add into this tens place value. So we have 40, because remember this is actually 40, plus 10, because this is actually 10, and then we have 0. We don't have any 10s here. So we have 10 plus 40 is 50. We're only going to write that down as a 5, because just like up here how we just wrote a 4, but it still represents a 40 because of the place value it's in. We didn't have to regroup anything, so now we can just do 200 plus 800. 200 plus 800, 800, 900, 1,000. So again, we went into a different place value. We went over our hundreds place value. So we are going to write a 0 here because we went into 1,000. Remember, 800 plus 200 equaled 1,000. We don't have any hundreds in the hundreds place value spot. It all went to the thousands. So we just wrote a 0 there because there's no hundreds. And then we're going to regroup, and we have a thousands place value now, but there's no other thousands to add it to. So we're just going to bring it down, and we have 1,000, no hundreds, 50, and then 1,051. I would like you to try this one on your own. The mayor of your town wants to make sure she has enough pamphlets to pass out at the town parade. She has both of her secretaries count them for her. The first secretary counts 479, and the other secretary counts 508. How many pamphlets will the mayor have? Go ahead and pause your video and work on that now. Here's the number sentence you should have written, and then your answer would have been 987 pamphlets, because we added 9 plus 8 equals 17, so we brought down our ones place, and then we regrouped our tens place because 17 has a tens place and a ones place, and we added 10 plus 70 to get 80. Nothing to regroup there because we didn't go beyond our place value, and then 400 plus 500 equals 900. Now we're going to move on to the subtraction algorithm. I'm going to show you again what it looks like with the base 10 blocks, and then I will show you without the base 10 blocks, then we'll try one together, and then you'll try one on your own. So for this one, when we think about subtraction, remember, we start with the whole, and we take away the part. So we're going to represent this a little bit differently than we did with addition. With addition, we put in the two parts, and then we combined them to find the whole. With subtraction, we're putting in the whole and then taking away parts of it to find the other part to make the whole. So we're going to represent 536 because that's our whole. So here is the representation of 536. We have 5 100s, 3 10s, and 6 1s. Now we're going to take away 219 from that. We're going to start in our ones place over on the right hand side. So we are going to start, I'll erase these. We're going to start right here. We have 6 1s. We have to take away 9 1s because 219 has 9 1s. But we only have 6, so I could take away 1, 2, 3, 4, 5, 6. I don't have enough to take away anymore. So, very similar to addition, I'm going to regroup. I'm going to take one of these 10s and break it up into 1s and bring it over here to help me. The way I'm going to do that in my algorithm is I'm going to come over here and say, okay, I have 30. I'm taking one of those away, one of those 10s away, and I'm bringing it over to my 1s. So now I have 20 over here. And I'm going to cross off my 6 as well, because now I have, Remember, I had 6, now I'm adding 10 more because I brought a 10 over from here. I have 16. I'm just going to draw these blocks in here. So I'm going to draw in 10 more blocks. And because I took those 10, and remember I took them from here, I'm going to cross this one off. Now I can finish. I took away 6 already, so I'm going to take away 7, 8, 9. I've taken away the 9 that I need to take away. And now I have 1, 2, 3, 4, 5, 6, 7 ones left. So I'm going to write that in my ones place because that's how many ones I have left. Now we're going to move on to the tens place. I have 20, and I have to take away 1 10. I can do that. And I have 1 10 left, so I'm going to write a 1 to represent 1 10. Now I have 5 hundreds, and I need to take away 2 hundreds. I can do that. 1, 2, and that leaves me with 3 hundreds. So 317. Let's try one without the base 10 blocks. Alice and her friends are working to collect $350 for a charity. Alice has collected $162 already. How much more do she and her friends need to collect? How are we going to represent this number sentence? Well, we need to get to 350. That's our whole. And we already have part of it. We have $162 of it. So we're going to represent it by saying 350 because that's our whole, minus the part that we already have, 162, to find out the part that we still need. So, where are we going to start? We're going to start in the ones place. So, we have 0 ones up here, and we have to take away 2. Oh geez, what are we going to do? Well, we can regroup. We can go and grab one of the 10s from over here and make this a 40. And then come here and say, all right, instead of having 0 ones, now I have 10 because I took 10 from here. So 10 minus 2 is going to be 8. Perfect. But we're not done. Now let's go to the 10s place. I have 40 and 60, so I have to take away 6 10s from 4 10s. If I only have 4, how can I take away 6? I'm going to have to go borrow from the hundreds place, or regroup. So I'm going to take one of these 100s and make this 200, and I'm going to bring that 100 over here, and I'm going to write it like this. But that's not actually 14, is it? It's saying we have 14 10s. 14 10s is actually 140. So 14 10s minus 16 10s, or 14 10s minus 6 10s is going to leave us with 8 10s. Perfect. Still not quite done. Let's move to our hundreds place. We have 2 100s minus 1 100. That leaves us with 1 100. So they still need $188. We're going to try this one together now. Tristan and Lily know that they planted a total of 792 potatoes. They have already harvested 464 potatoes. How many potatoes are left to harvest? I'd like you to pause your video and write out how you're going to write this number sentence. You should have it written out as 792 minus 464 because we know we have our whole of 792. They already found 464. Now that's the part. And then we need to find out what other part will get us to 792. Now, I'd like you to start in your ones place, right over here, and pause your video and subtract the ones place. To get your answer, you should have said, oh, I only have 2 ones, and I need to take away 4. So I'm going to regroup, grab a 10 from over here. So now I only have 8 10s here, but now I have a total of 12 because I added 10 to 2. So now I have 12 12 minus 4 is 8. And then I'm going to go over here. 8 tens minus 6 tens is going to get me 2 tens. 7 hundredths minus 4 hundredths is going to get me 3 hundredths. So 328 potatoes left to harvest. Now you're going to try this one on your own. Go ahead and pause the video and do that now. We're going to start, as always, in the ones place. We have 7 ones and we have to take away 9 ones. But we can't do that. So we're going to have to go grab a 10 from the tens place. Right here. But this says we have 0 tens. So what are we going to do? Why don't we grab a 100 from the hundreds place and bring it over to the tens? So now we have 4 100s and 10 tens, right? Because we brought over our 10 tens to our tens place from one of the 100s. And now I have a 10 that I can go grab. So let's go back to the ones place. Remember, we need to go grab a 10. So let's grab it. Now we have 9 over here, 9 tens. I have 17 here because remember, I grabbed a 10 and I brought it over to my ones. I already had 7 ones and now I'm adding 10 more. So 17 minus 9 is going to get us 8. Now let's subtract our tens place. We have 9 minus 8 is 1, and 400 minus 300 is 100. Very good. All right, so you have just learned 2 kind of difficult algorithms, but you've done a great job sticking with it. If you need to review anything, go ahead and rewind the video and watch it again. But for now, we're going to do our Think About It question. Of all the strategies and algorithms we've learned in the last several lessons, which ones work well for you and which ones do not work well for both addition and subtraction? Go ahead and think about that between now and the time you watch the next video. See you later.